Welcome to math class where math makes sense. That's the goal. Welcome to math class where math's our friend. Feel the math love. Come feel it with me. Today we're talking about systems of equations and when to use the elimination technique. Okay. There are some systems. Now remember, systems are more than one equation. In this case, we're talking about linear systems where I have two linear equations. We can do nonlinear systems. We can do three-dimensional systems where we've got three variables and there's all sorts of different types of systems. Right now I'm doing linear systems, two linear equations. And you notice all of these have two linear equations, an x and a y with no exponent. And so one of these is like screaming to eliminate. Here we go. When opposites are given to you, what is it screaming to do? Eliminate, 8. What do I mean by opposites? Okay, 3x and x, those are not opposite. No. Y and negative y. Oh, they're opposites, y and negative y. So when opposites are given to you, what is it screaming to do? Eliminate, 8. Those go to 0. 3x and x is 4x. So I say 4x is equal to 15. When we eliminate, you eliminate and then you just combine, which is adding, right? We're combining. Okay, once I get 4x is 15, that means that x is 15/4. What I would now do is plug this x value back into one of these equations. It doesn't matter. I would probably choose this one because it's pretty easy to solve for y from there. I'm not going to do that part right now. That's for another video, but I'm just showing you which one of these is like set up for elimination. Okay, so that one was really when opposites are given to you. Ooh, what is it screaming to do? Eliminate, 8. Eliminate, combine, solve. This one is the next type. When variables are the same. Okay, so the y and the y, the variable is exactly the same. When variables are the same, change all the signs and then, okay, we gotta subtract this entire thing. So often in textbooks, I'll see them say like, now subtract. If they're the same, you subtract. But what happens is that we inevitably, we meaning like so many students everywhere, forget to subtract the whole thing or distribute that negative. So what I like to say is, when variables are the same, change all the signs, and then, okay, now we just eliminate 8. Eliminate 8. Okay, this now eliminates to 0. It's a y and a negative y now. We combine to get 2x. We combine to get -5. All right, so x is -5/2. I'm going to take that x, plug it into one of these equations, solve for the y, and I get my point. Okay. Well, what if I don't have either of those scenarios, but at least the variables are lined up? So look, do you see how everything's lined up? The x's, the y's, and the constants. Here, are they lined up? No. This one is where it's really screaming at you to substitute. The y is already solved for. I already have an expression that's equal to the y. And so it's asking me to substitute that in here. Like it's like, substitute me. This one's like, eliminate me. This one's like, yeah, hello, make one of the negative and eliminate me. And this one's like, you could solve this for the x and substitute, solve this for the y and substitute, but elimination would be pretty easy because when variables are all lined up, multiply through, then what? Then eliminate. Multiply through. Let me set up opposites. Okay. I'm going to choose to multiply through the bottom one by -3 to set up an opposite for my x. Alternatively, I could choose to multiply the top one by -2, which would set up an opposite for my y. It's your choice. Mathematics is creative that way. There's a lot of choice. What do you see? What do you want to do? Okay, I'm going to multiply the bottom one by -3. So this becomes -3x. Multiply through is telling you multiply through that entire equation. It's telling you to do that distribution. It's using that kind of language. Multiply through. So -3, this becomes minus, right? -6 y, and this becomes minus 30. And now, multiply through, then what? Eliminate, 8, 8, 8, eliminate, 8, 8, 8. That gets me a combined negative 5y. This gets me a combined negative 25. So y is divided by the negative 5, positive 5. And then you would plug that into one of the original equations. I wouldn't do it to the manipulated one. I'd probably use one of the original equations. That's a better way to check yourself. Plug it in, get your other variable. In this case, we'd get our x. And you'd be good to go. All right, so the song walks you through the 3 main places where you would probably want to use elimination. When opposites are given to you, what is it screaming to do? Eliminate, 8, 8, 8. If variables are the same, change all those signs and then eliminate, 8, 8, 8. If variables are all lined up, multiply through, then what? Eliminate, 8, 8, 8. And if you got a situation like this, where one of them has already solved an expression equal to a variable, oh my goodness, people, just substitute. Just substitute, okay? That's another video for another time, and that's another song, too. Eliminate is on Funky Functions, out now, wherever you get your music. Check back, subscribe to the YouTube for more lessons like this. To feel that math love, subscribe, like, follow, share. Find me on all the things. I really appreciate it. That helps me spread the math love. And remember, math loves you. Bye.